Excellent. So let's get started. Today we're going to talk about frameworks and what they do for you. So we'll talk about React, we'll talk about Angular, we'll talk about the view, the UI, how to treat your state and how to refresh the UI. We'll talk about URL routing and all these things. Yeah, let's just get started. Good. What's this? All right. Can we do this? Okay, good. So as I mentioned before, I don't really want to go into the details of any specific framework. I will use React for the homework, and I encourage you to use React mostly because there are a lot of great resources, and it's fairly simple compared to other frameworks. So as a framework to learn for you, I think it's a good choice. But otherwise, I want to spend time looking at what frameworks do for you and how they do it. And maybe you can develop some independence from frameworks, not be tied to a specific framework. And when the ecosystem changes, I hope you'll be able to catch up and keep going and learn the next framework after that. Right? So we are going to look underneath the surface of some of these frameworks and talk about how they do things. Okay? Good. So first off, what do frameworks actually do? All right. So depending on the framework, you'll get different capabilities from each one. So React, for example, is meant to be more of a view layer. So it allows you to build an app, build components, and it's ostensibly that's all it does, although it can do quite a bit more. And other frameworks are the same. So if you look at Angular or Ember or things like this, or Aurelia, Vue.js, they tend to help you with the view layer quite a bit, and then they'll add things on top. So you'll have a framework way of rendering views. So you have a bit of HTML, a bit of data, and how do I put that on the screen? And then you'll have a way to modify the UI. So this is about having a bit of state, maybe something that will change over time. And if it changes, you want the UI to reflect those changes. So you'll have a framework way to do this, mostly data binding. And then you also have URL routing. All right, so this is an important one. URL routing usually, like traditionally, was taken care of on the server side. You would put a URL in your browser, and it would go to the server and fetch that resource. Now with these front-end frameworks, the paradigm is changing, and the client side has to take care of the URL routing. So that means taking care of what to load at which URL. How do we make big bookmarks work? How do we make back and forward buttons work? And how do we specify a link to a different section of the page? That kind of thing. And then all the frameworks, or mostly all the frameworks, will also have a way for you to test your app, either unit testing or component testing or browser testing, or all of these things together. And yeah, and the frameworks will give you a way to talk in between your components. How do you share messages or data between components? Good. And then some frameworks will just go the whole way, and they'll help you deploy to mobile, rendering views on the server, or interacting with Server API. So you have different things that you can add on to these frameworks. They can do a lot of things for you. They are a powerful modern tool, and that's why we use them. Not a lot of big sites are not using frameworks. So most big sites are using frameworks anymore. At this point, it's a good idea. Although you definitely don't want to be tied to one. You don't want to be stuck with a framework. You want to understand how it works. So let's just go through each of these capabilities over here, and then we'll talk about how this works. And if you have questions, feel free to interrupt me. That's totally fine. We can talk about how things are done in your framework and how that compares to others. Good. So when it comes to rendering views, I see two main strategies. So let's just outline the problem, right? So you want to show something to the user. Maybe they click the link, or maybe they entered a to-do in the box, and basically you want to update the UI and show some result. And as you do this, it's not just showing some HTML. You probably want to customize the HTML to also include some bit of data. Maybe it's the username, maybe it's what they put in the box. So you want to customize that data and just show it in the browser. Right? So let's just have a look at the first strategy, which I'm calling custom templating. Okay, and so this is about using a completely custom HTML language, if you will. So here's an example. We have a UI on the right. So you'll have, so the browser is showing you a view, and that view is constructed not on the server, but on the client side. Okay. If you look at, let's just look at the HTML first. A little bigger. Yeah, good. So here we have the HTML behind the view on the right. You'll see it's pretty simple. And here's what I mean by custom templating language. So I'm using x-4-each to-do and to-dos. Okay, this is not HTML. This is not JavaScript. This is just me saying that this is going to be the way it works. I'm just specifying a custom language. Whenever the developer is going to put in x-4-each, I will take the content of this div and I will just loop it through and generate the content of that div once for each to-do in to-dos. Right? So this is also custom. It's completely made up. It's not JavaScript. I'm specifying that you can use a language like this. Right? So to-do becomes a variable that you can use inside the body of that div, and to-dos presumably is a list of things. Okay, and then here inside that div, I'm specifying that you can use curly braces to interpolate values. So it's going to take the to-do, which is the current object, and grab its text, and it's also going to do something very similar using the created@. Property of that to-do. So none of this is standard. It's just custom. You'll recognize Angular style in something like this. Maybe also Ember and things like this. Good. So let's see how that can work. The first thing we can dispatch is the CSS. So because I'm using x-4-each here, I don't expect this raw HTML to show on the page. So the first thing I'm going to do is in my CSS, I'm going to say all the elements with this attribute, x-4-each, just don't display them. Display none. And so all the elements on which you'll be using my custom language will just disappear from the view. And then the JavaScript is responsible for using those components and rendering them. Good. The rest of the CSS is just basic styling. Good. So let's have a look at the JavaScript. Okay. At the top here, I have the data. Okay, so I'm calling this scope, maybe in the spirit of Angular, but you should just see this as the data or the state. I'm going to use both state and data interchangeably. Okay, so it's just some data that you might be getting from the server or from a database or from the local storage or from a service worker. Doesn't matter. It's just a bit of data, and presumably it can change over time. But right now, that's the current state of our data. Right. So here we have a scope, which is just the main data object, and inside that we have a list of to-dos. Okay, and that's all it is. Each to-do has a bit of text and a created@date. Good. Now, so let's just have a look at how I'm making this custom language work. The details of the code aren't super important. I'm just going to go through quickly and talk to you about how it works at a high level. If you want to know more and understand properly, you can just go to this pen and see for yourself. So let's see. So that's the gist of it here. On when the browser is ready, right, on content loaded, we get started and we look for all the elements that have the x-4-each attribute. Right? So you're using our custom language. We grab those attributes. Here we know there's only one, so it's a little simpler. But basically, I'm selecting the for each, and then I'm assigning a variable template, and that's going to be the content of that div. Right? So I'm treating that as a template. It's currently display none because of the CSS, but that bit of code is going to be the template, and I'm going to try and render it. But I have to be careful because of that curly brace rule, right? So every time the developer is using curly braces, I want to be able to interpolate values in there. And I also have to look at the value of the attribute, to do and to-dos, and actually make it make sense. So this is what we do next. Here, I'm looking at the x for each value, okay? And I'm using split to split into 3. So it's going to give me the object and then object in collection, okay? And in is just dismissed, it doesn't matter. And I'm grabbing the object in the collection. And at that point, I can start evaluating the inside of the template and evaluating whatever's inside curly braces. So this is what's happening here. I'm using the scope, which is the data, and I'm grabbing the collection from it, okay? So in the HTML, when the user is saying to-dos, that's going to be to-dos from the scope, to-dos from the data. Okay, that's what's happening here. And then I'm looping through them. And for each one, I'm evaluating the template. I'm looking for curly braces, okay? And for each set of curly braces here, I'm evaluating the code. You'll see here, line 21, I'm using eval, which is just a way in JavaScript to evaluate JavaScript, okay? And here, I'm just evaluating the inside of the curly braces and replacing the curly braces with the result. So I'm doing that in a loop, once for each set of curly braces. When that's done, that's it. That's our content, and that goes into the HTML. And then here, I'm just taking the for each element and just replacing its content with what we computed earlier, and then I'm setting the display from none to initial. So now it's going to show the result of the computation. So you could extend this language. Here we had for each, which is useful, but you might need if, or you might need else, or you might need just a different construct in that language. And if you've used Angular or Mustache or Ember, then you'll know the kinds of things that you would expect from a language like this. But at its core, it's a pretty simple mechanism. Right? So that's the goal of this example. It's to demystify what's happening here. Does that make sense? Any questions on this? No? Okay. Just to make sure it's clear, I'm going to come here and let's talk about what can be changed. All right. So here I can instead of to do, I'm going to say T. Okay, and that's allowed, but I'm going to have to change to do for T inside the template as well. Okay. And that should be fine as well. That works well. And but to-dos, that's coming from the scope. That's coming from the state, right? So I can't change that without changing my state as well. So I could call this list of to-dos. That's also allowed, but in my JavaScript, I'm going to have to go in my state, and instead of to-dos, I'm going to have to call this list of to-dos. So now,
the state, sorry, hello. The state basically, well, the scope, that's just a collection, isn't it? It could be like anything, like a JSON object, or that, as long as you kind of refer to that correctly, you create like the instance of it to iterate through each one.
Yeah, that's right. So it's, I mean, JSON is text, right? So I think you meant just a JavaScript object, right? So that's what it is. The scope is just a JavaScript object, and by default, I'm just making its properties available to you in that for each language.
Okay.
Where is that display none happening? Why do you have to set the display to initial?
Yeah, it's in here in the CSS.
Okay.
The problem, if you don't do this, the browser might render the HTML, including your templates. Right? So you might see this, the raw HTML with curly braces in your browser, even if only for a fraction of a second. So in order to avoid that, I just set every element with x for each as display none. Good. So that's one strategy for rendering the view. It's one that's used by many frameworks. Let's try a second strategy. This one I call HTML JavaScript. So this is about utilizing JavaScript as much as possible in order to render the view. So here in the CSS, there's nothing special. I'm going to minimize this. And in the HTML, we have something similar, except this time we actually have JavaScript code. Okay, so the first difference is that I'm using the template tag. Okay, and the template tag is pretty useful for frameworks, and it's going to be a tag where you can put in some code inside your template, but the browser is not going to render it to the user. Right? So whatever you have in the template tag here, you can just clone and copy. You can do whatever you want with the template, but the browser is just going to ignore it. So that's also one way to solve the problem of the browser showing you your raw templates in the browser.
Is that tag added by HTML5 or JavaScript?
HTML5. Yeah. So yeah, I think it's standard in HTML5. Good. So yeah, so that's the first difference. But that's not really that's not the core of this strategy. Right? The core of the strategy is the following. Inside that template tag, I'm actually using JavaScript. Okay. So here I'm not using a custom HTML attribute. I'm not making up a language. This is valid JavaScript. Okay. So I'm using the backtick so that I can have multi-line strings. And my interpolation is done by JavaScript. I'm using the dollar braces. That's totally standard JavaScript. And that's it. So, and I'm doing my iteration here using scope.todos.map. So scope remains the global state object, and I'm going into my to-dos collection, and then I'm mapping over it. So this is totally valid JavaScript. The only bit that's missing is that we're going to have to execute this code and make scope available. So that's what this code here is doing. We have something similar to what we had before. So our state here is called list. So it's just a list of to-dos. That's all. And in our event listener here, whenever the browser is ready, we are selecting our template tag, and then we're evaluating the content of that template tag. Okay, and then we are creating an element, a div, adding the HTML, the result HTML to that div, and just appending the div next to the template. Okay, so the result is going to be just the next child after the template. Okay, and we are using eval in a similar way here. All we're doing here is using eval in a function so that the template code here is going to have access to the local variables. So it's going to have access to scope here. Okay, so when I call evaluate template on this line, the second parameter that I'm passing in, that's going to be the scope. So if I wanted to, I could evaluate different templates with different scopes. All I have to do is change that second parameter there, and then scope as a local variable here becomes available in the template. Okay. So yeah, just to reiterate, the code inside here is inert. Nothing's going to happen until the JavaScript comes in and actually executes it. So you have to come in, select the template, and eval the content of it. So yeah, that's the second strategy. It's one that is used in React. Any questions about this?
I'm still a little bit confused about the scope thing, because at the moment here you got let list as opposed to scope in a previous example, and the second one scope. So scope is that what encompasses everything that you're trying to evaluate? So everything inside scope is what you're dealing with. Is that what it means?
Yeah, sort of. That's what I want it to mean. But that's what it means because of what I'm doing here. So when I call eval here, I'm evaluating the code from the template. Okay. So template is just a string, and it contains the content of that template tag. So I'm evaluating it. I'm asking JavaScript to just evaluate as code. Okay.
Mhm.
And then as I do this in that context, the code will have access to variables here. So if I had a variable here called let names equal to Matt, right, then the code would have access to a variable called name.
Okay.
So within that context, I can create stuff for that code. And it just so happens that there is a second parameter here called scope. Right? So the template will have access to its environment, to the scope variable. And I'm just choosing to make that an object that contains to do and points to my list of to do.
Oh, I see. Okay.
Yeah.
So it doesn't matter what scope is. It could be anything, basically, as long as you want to access it.
That's right. Yeah. It could totally be anything. And yeah, here I'm just specifying that scope is going to be this object that points it to do. So it could be your global state, or it could be a reference to a store. It could be anything.
Okay.
Yeah. Good. So as you can see, some of these different behaviors they're easily replicated. Right? You don't need a library. You don't need a framework to do all these things. So yeah, so it's pretty simple when you want something like that to happen. Good. So let's move on to the second category here. So we know how to render a view, but when our data changes, we don't yet have a way to update the UI. So maybe you've just received a push notification and your state has changed. Or maybe the user has removed a to-do from the list or added a to-do to the list. And so at that point, you want to refresh the UI. So one easy solution would be to just rerun that code again. So you could just rerun this function again and just do the whole work again. But that tends to be not very efficient. And it tends to be complicated to keep track of all the things that need to change whenever state changes. So it helps to have a better strategy. So in this category, I see three main strategies. The first one I call observer or proxy pattern. So let's have a look at what that looks like. Okay, so first off, let's have a look at the app here. So this is just a simple to-do list. Here I'm going to say get bread. I'm going to press enter, and then get bread goes into the list here. And I can do that multiple times. Okay, so here the app is responding to user action, and my state will contain those two to-dos, and then the UI is going to show them. Okay, so this is interactive. This is different from the previous two examples. Right, we have a UI that is going to stay up to date with the data. So let's have a quick look at the HTML. There's nothing special here. It's just pure HTML. And then the only thing that's maybe interesting here is line 15. We have a div with ID display, and that's where the template is going to be rendered. Right? So whenever there's a to-do, it's going to be rendered in that div, in that site. Good. So let's see how that works. So here we have again a state object. I'm calling this one to-dos, and it's a list. Okay, and I'm defining two operations that you can perform on that state. One is add to do. It takes a bit of text and pushes a to do onto that list, and then remove to do does something similar. And then here I'm defining one-way binding. Okay, so I'm defining one-way binding in different directions. So the first one here is append to do to UI. So that's going to be a function that's going to take a to do object and add it to the UI. Okay, so it goes from state to UI. That's the one way I'm talking about. Okay? So it takes a to do object, and then it doesn't do anything special. It just creates some HTML, and it's going to append the to do to the UI. Okay, that's all that this does. And then here's another one-way piece of behavior. So whenever the form is submitted, okay, I'm grabbing the value of the input. I'm calling add to do, so that a to-do is pushed onto the state, and then I'm clearing the form. Right? So here, the one way is the opposite. So we're going from the UI to the state. Okay, so the user enters a new to-do, we capture that, we add it onto the state, and then that's it. Nothing else happens here. In the next function, there's another one-way relationship that's defined here. So refresh to the UI. So this one is similar to the previous one that we saw, but it's gonna refresh the UI for all the to-dos. Okay, so it's actually gonna loop through all the to-dos and refresh the UI. Okay, so it goes from state to UI. That's it. Good. So we have all these bindings set up. We can go from UI to state or state to UI. And so we just need a way to bind these together so that when I add a to-do in the form and it's pushed onto my state, I also want the UI to be updated automatically. Okay. And then this last bit here actually performs this magic. Okay. So in this case, I'm using the proxy object. Okay. So this is a new ES6 way of doing things, but you could also fake it using other more elaborate tricks. Okay, but basically a proxy object will just wrap itself around an object, and within the proxy object, I get to intercept function calls. Okay, so here I'm wrapping a proxy around the to-dos list, around my state. Okay, and whenever a to-do is pushed, my proxy is going to have its set function called. Okay, and so it works like this. So the set function has the object, which is the original object, the property is the property you want to set, and the value is the new value. Okay. So here, whenever you set something onto the to-dos proxy, I'm actually going to set it in the underlying object, and I'm also going to call refresh to the UI. Okay. So with a mechanism like this, with a proxy that intercepts the pushes onto the state, I can guarantee that the UI is going to be refreshed whenever a to-do is added onto the list. So it's a bit of magic here, and that bit of magic could reside anywhere. It could be in a framework, it could be in a library, it could be in a different module. But what matters is that the result, the to-dos object here, is no longer just a state, it's a proxy of the state, and whenever you change that, the UI gets refreshed automatically, which is neat.
What do you mean by proxy in this instance?
Yeah, so it's so yeah, synonyms for that would be delegate, a wrapper, an interceptor. Right, those would all be the same thing. But a proxy is an ES6 object, and it allows you to do something like this. Right, so it wraps around an object, and then you get to intercept function calls to that object.
Okay.
Yeah. Good. So yeah, so that's the first strategy, to keep UI and state in sync. So let's just have a look at the second strategy. The second strategy is the virtual DOM. So the virtual DOM is the one used by React. The observer or proxy pattern is used by Aurelia, Knockout, and other frameworks as well, I'm sure. So let's have a quick look at the virtual DOM. Here. Good. So let me come here. Okay. So this virtual DOM idea is fairly new, and it's based on the assumption that DOM manipulation is a bottleneck. Okay. So all these front-end frameworks, they have to look at the UI, they have to update the UI often. So whenever you add a to-do, it has to go into the list. And if you sort the to-dos, then the framework has to do a sorting of those to-dos. And if your list of objects is coming from the server, then it might have to be refreshed quite often. And then all these DOM operations where you add an element or remove an element, or change the content of an element, that's considered to be a bottleneck. It takes a long time, all things considered, and the virtual DOM is an idea that makes that bottleneck less acute. So it's meant to be like a fast solution to updating the DOM. Okay, and it's been embraced so much that a framework like React is really embracing the virtual DOM. And you could say that the whole architecture of React and the way you build an app is it's kind of recreating the virtual DOM idea in your code. It impacts your whole architecture, your whole code. So the virtual DOM is just that. It's the framework taking your DOM, taking all your elements on the page, and just creating a copy of it. But it's a copy that's going to be in memory. Okay, and the idea is that whenever you make changes to the DOM, it's going to start by making those changes in memory, and that's going to be really, really fast. And at the point where it knows it can update the UI, then it's going to update the UI, but only on its own terms. Right? So if you decide to update the DOM 3 times in a row, you might update it 3 times in a row in memory, but only once in the actual browser. Right? So you get to batch your actual updates to the browser. You get to debounce them. Right? You get to only make real updates, maybe only every 50 milliseconds, something like this. Basically you get control over when those updates to the actual DOM are going to be made. Yeah. And that's it. And whenever you make manipulations in memory, it's going to be way faster. And the last idea is that when you're done making those manipulations in memory, you can look at the result of that virtual DOM and compare it with the actual DOM. And then you can calculate the difference between the two, and you can potentially only apply smaller manipulations, smaller differences onto the actual DOM. Right? So when you regenerate your virtual DOM, you might realize that actually some things are exactly the same as the actual DOM, so you won't have to update them. Right? So you get to save some operations there. Okay, this is really an optimization technique, but it's just become so pervasive with React and Preact and Vue that this is something that we have to cover. Okay, so here we have an example. Right? So we have a label welcome and account 0. There's some state backing this app, and when I click the button, the count changes. And let's this is not good enough. Let's just have a look at the code behind this. Okay, so we'll have a vDOM global object. That's going to be our virtual DOM, and then we'll be able to change its state to refresh the tree, and we'll be able to refresh the UI as well. Okay, so let's see how this works. This is the HTML for it. There's nothing special here, and there's nothing special in the CSS here. Okay, so this is just pure HTML, not a problem. Okay, and then here, this is a JavaScript. Okay, I'm using a virtual DOM library. This is just a library that works like React, but it's not React. Okay, it's not a framework. It's just a virtual DOM, just a pure virtual DOM library. Okay, so here I am creating a virtual DOM object. In it, there's going to be a tree, which is the virtual tree of elements. So it's not the tree from the browser. It's just a copy, an in-memory copy. There's going to be a root node, which is the top node of that tree. And sorry, the root node is going to be the place where the tree is going to go into the page. So it could be the body, but it could also be just any element on the page. That's where the virtual DOM is going to consider its top to be. Okay. And then here we have the state. So we have a label, which is a string, an account 0. That could be anything. That could be a list of to-dos, as we had earlier. It's just data. Good. And then here we have the actual smarts of the code. So the init function is going to get things started. So the first thing it's going to do is render a new virtual tree. Okay, so it's going to pass in the state to this render method, and then the render method is going to know how to build a tree the state. Right? That's the responsibility of the render method or function. And then that's going to give us a tree. So that's the whole representation. And then the root node is going to be appended to the body. Right? So at the end of the body, we just add this, and that's it. So the render function here is using this maybe strange language, but it's really just generating some virtual HTML. So H is an element, so that's how you create an element. And then here I'm just creating a div element with ID root. Here I'm just creating a P element with no attributes and that content. So it's going to have a label, and it's going to use the state to show the label in there. So this is just creating HTML. Okay, that's it. And then we are returning this bit of HTML as the tree. Okay, but it's all virtual. Nothing's been done yet to the page. Okay, and then refresh is the last bit. So whenever we call refresh, it's going to look at the state. It's going to re-render the tree. It's going to compare it with the current actual page, and then it's going to apply the differences. Okay, the differences between the in-memory tree onto the actual tree. Okay, so here we re-render a new tree. We look at the differences between the two, and then we patch the actual DOM. Okay, so that's what refresh does. So whenever the state changes, all we have to do is call refresh, and then the UI will be updated. That's it. Okay, and so here that's kind of what we do. So in DOM content loaded, we're looking at the button, and whenever you click that button, we are going to update the count. So count ++, so the state is changed, and then we just call refresh. And that's it. So the virtual DOM is going to know to re-render itself, compare itself to the previous instantiation. It's going to see that this P element has a different content, so it's going to change only that little P element. It's going to be pretty smart in that way. And so here, yeah, we get to click this button and have the UI refresh automatically at the bottom. And if you want to change the label, we can also do that. Right? So I'm going to take the state and change it for hello, and then I just have to call refresh, and then the virtual DOM is going to do the minimal changes in order to reflect the state. Now it says hello.
So what you call here by the new tree is not the entire kind of scope that you created. It's just the changes themselves. Is that right?
New tree. Well, yeah. So the new tree will be the complete tree, right? So you have the actual tree in the page managed by the browser, and that obviously is complete because that's all we can see. And then you have the virtual tree, which is complete, but it's in memory. And whenever we call refresh, it's going to compare the two, and it's going to apply only the differences.
Okay.
So if your in-memory tree doesn't have an element, it's going to see that as a difference, and it's going to remove that element from the actual tree.
So at which point does it decide to then update the DOM itself then in this instance?
In the refresh function. Okay. So when you call refresh, it's going to re-render itself completely from the state. Okay. And then it's going to diff the two. So this is like a git diff. It's going to look at the differences between the in-memory tree and the actual tree. And then the last step is to patch. So it's gonna take the differences from the in-memory tree and apply them onto the actual tree.
Okay, so he is actually applying the changes to the DOM then. You just check it first. Okay.
Yeah, it is, but it's going to be very minimal, right? So if you change the value of label, okay, it's not going to replace one tree with another. It's going to understand that there's a p tag in both trees, and in memory, the p tag has a different value. So it's going to understand that, and then it's going to go into the actual tree and apply that change right there. It's going to be very small, very minimal as a change.
And is that what people used to call Ajax before? Like
no, that's something else.
Okay.
Yeah, Ajax is about server, like making asynchronous server requests.
Oh, right, okay.
Yeah, so it's more about network than anything else. So yeah, so a virtual DOM like this is used by React, React, and Vue.js. It turned out to be a good idea. It makes your apps fast, and it gives you a very intuitive way to architect your apps. So you can have different components, and the components are placed in a tree structure, and each component is responsible for its own state. It has to. You'll have something very similar in a React component. You'll have a render function, and the component knows how to render itself. It might even use other components, and then you'll have a tree of components. And whenever the state changes, whenever something happens that has to trigger a refresh, then React is going to use the virtual DOM to figure out the changes, and it's going to apply only the minimal changes to the actual DOM, saving you a lot of time.
At what point, you said this, the diff is happening between the virtual DOM and the UI, and at what point does the DOM, I mean the backend on the server get changed, and what controls that?
Okay. Right, so that's not something we've talked about so far. So far the state is in the browser only. There's no communication with the backend.
Got it.
Yeah. So I mean, if you wanted to communicate with the backend, it wouldn't be so difficult. So here we've just changed the state, right? We've changed the count, and so at this point you would have to go tell the server that the count was changed. Good. And for that, you could use a proxy as well, and you could make things automatic so that you don't have to worry so much about keeping the backend in sync. It's always nice to have a solution that allows you to just manipulate the state, and whatever changes need to be made to the UI or to the backend could be automatic. Good. So that's it. And then there's a third strategy, which is used by Angular. It's called dirty checking or change detection. It's a little less clear how that works, but it's a different way. It's a different way for Angular to understand that the state has changed. And once Angular knows that, it's going to refresh the UI. Right? So if you use Angular, maybe you've had a controller with a scope, and then whenever you change something on that scope, Angular is really running before you and after you. Right? So after you've made that change, Angular is going to look at the scope. It's going to realize that actually you've changed something, and then at that point, it's going to update the UI. So the concept here is a little less generic. So yeah, so I think I'm just going to skip that strategy. But you could have a look at Angular and some documentation there if you want to know more about that. Good. So let's see. Yeah. All right. Good. So let's move on to URL routing. So this is a very useful thing. It's pretty painful to build that on your own. So let's see. So URL routing is about quite a few things. So I think we mentioned a few of these before. So we want to load the right page given a URL. So if I have a bookmark or if I send a URL to you by email or on social media, you should be able to use that URL and actually go to the place that I was. That sounds silly. That's something that we get for free when it comes to like server-generated websites. But when it comes to front-end only apps, it's not that silly. You need a way to go from a URL to a piece of content, to the right view with the right content. So routing is about that as well. Yeah, and then each page that you have might require some data. All right, so if you have a list of to-dos and you click one, you're gonna have to go to that to-dos page, and then that page will need a way to figure out, okay, I'm actually trying to look at to-do with ID number 1. And so that will most likely end up in the URL. And you might have something like /do/1. That's going to be your URL. So your URL router will have the responsibility to instantiate that page and give it the right parameter. So maybe that page can say, okay, I need an ID in the URL. I need something in the URL for me to be able to render. So that's what the URL routing is about. And most of these URL router libraries will use the history API to manage the back and forward buttons, and also to manage going to the right place when you refresh or when you share a link. So let's have a look at how that works. Good. Okay, I'm going to full page. Okay, let's see if that works. Okay, so here we have a simple site with 3 tabs. Okay, we have news, weather, opinion. And if I click weather, I go to weather, the content changes. If I click opinion, it says opinion, and the content changes. Right? So I have 3 different pages. Okay, and unfortunately, so this mode isn't letting me show you this properly. Let me log in here. Beautiful. And debug mode. Good. So yeah, same thing here. So news, weather, opinion. But now you can see when I click weather, you can see the URL changes. It says /weather. Now opinion, it says /opinion. And then news, it says /news. Okay. So the user is moving onto different sections of your app, and then the URL changes to reflect that move. Right. So that's an important connection you want to make. And then if I take that URL and share it on social media, people should come here and see news, not weather. So here it's working well. And if I go to opinion and then go back, it's going to bring me back to weather. And if I go back again, it's going to bring me back to news. And if I go forward, it's going to bring me back to weather. Right. So here we have normal behavior. I mean, it's something that we kind of take for granted, but there's actually a bit of work necessary to make that work in a front end application. So let's have a look at how this works. Good. So first off, the HTML. Okay. So here we have regular HTML. I have a div for each tab. Okay. So this is class tab. Each tab is in a div like this with a different ID. And then in this particular case, or in my mini framework, if you will, I'm just specifying that in order to link to a page, you're going to need an anchor tag like this with an href that points to the ID of the thing that you want to see. So that's what I'm specifying here, and that's going to be my rule for the mini framework. So you want to see news, you say href news, and that's it. If you were in React, you would use a link component to do something similar. And so that's it. So this is a very simple example. The HTML isn't special. And in the CSS, we have something similar to what we had before. I'm taking each tab and making them display none, so that by default, you don't see anything. It won't show you all 3. It's going to show you nothing. And then the JavaScript is responsible for showing you the right thing. So let's see how that works. Good. So here, let's start here. When the browser is ready, okay, we are selecting all the anchor tags, okay, and whenever they're clicked, we are going to grab the href value, and that's going to tell us which tab we want to show, and then we're going to show that tab in the show tab function. Okay, and that function isn't special. It's just going to look for the right tab. It's going to make it visible, and it's going to make the other ones not visible. And that's it. Okay, and then here's the magic. We're using history push state. Okay, so this is a standard API in every browser, and it's instructing the browser to basically move the history forward. Okay, so we're no longer going to be wherever we were. We're saying go to this other state. Don't reload the page like in a traditional web app. Just register that this is a new state in your history. Okay, and then when we do push state, we can pass in a bit of data for us later. Okay, so here I'm passing in this page. This is an object that I want to use for myself later. It's the state. It's the state of the new history state. It's the it's a bit of state that I want to use later. That's going to be attached to that that place in the history. Okay, and then the second parameter is the title of the page, I believe, and the third parameter. Let me say page. I'm actually not sure what the third parameter is, but yeah, but maybe it's not so important. What's important is that we can change the things that you would expect to change, right? So you can change the page title, which is going to be in the tab, and you'll have a bit of state here for later. And then the question becomes, what happens when you go back? So when you go back, the browser is going to send an event called pop state, and you can register a function on pop state. And then here I'm just simply looking at the estate.page, right? So I'm looking at this object that I passed in, that I associated with my state, and I'm looking at the page. And if there is a page in that object, then I just go there. Show tab, right? So that's how the code knows to go straight to weather or straight to opinion if it says slash news or slash weather in the URL. Sorry, and that's the third parameter. There you go. So this third parameter is how the URL should change. Yeah, so page is just a value. So page is news, it's a string. So it's news, weather, or opinion. So yeah, so here we can navigate, we can push state, we can tell the browser, go there, go there, go there. Then if you go back, you're actually going to go back in history. And then if you load the URL, or if you go forward or back, then you get to run the bit of code during the pop state event. You get to refresh your app in whatever way you see fit. So yeah, so a lot of URL routing libraries will be using this API under the hood, and maybe even most of them will offer you a different way of doing this, which is maybe older for browsers that don't support the history API, although the support for the history API is getting pretty good. So this is the modern way of doing it. Any questions on this?
Yeah, can you give an example of the practical reason to do routing this way? Because it seems like it's counterintuitive, because you're growing the size of your HTML payload if you're keeping all content for 3 different pages on the same file,
sure.
as opposed to just loading the page the good old-fashioned way.
Yes. Okay. So in a traditional model, you would click something and then you would refresh the whole page. So it's good because you get to send down the wire only what's expected or wanted by the user. So if I click chat, I get to load the chat and nothing else. If I click my personal settings, I get to load my personal settings and nothing else. Right? So that's good. But it's also bad because every time I click and go to a different place, the whole thing is refreshed. Right? So the document is just dismissed, and then we're getting something new from the browser, and then we have to parse the HTML, parse the body, we have to parse the JavaScript, parse the styles. So a lot of the work is done again, and most likely a lot of this work is just waste, because we might have the same JavaScript, we might have the same styles. A lot of the page might stay the same, right? Maybe the navigation just really stays exactly the same, but we're going to have to re-render it and reparse it again. So it's not ideal. In a more ideal world, you would have a mix of both, right? So in this case here, we have content for each tab in this HTML, okay? But something else that we could do is in our JavaScript, we could understand that you're trying to look at weather, and we're not going to use the content on the page. We're actually going to go to the server and get it there, but it's only going to be the content for the weather section. And then we're going to take that content and show it to you in the UI.
Okay, makes sense. Thanks.
So that would be a lazy way of rendering views.
How do search engines handle this? Like, if it's not a separate page, how do the search engines know that the URL means provide me with different content, but give it priority over something else?
Yeah, that's a good question. It's something that we've been struggling with. All these sites require JavaScript, and you'll need JavaScript to get the content. And historically, search engines haven't used JavaScript. It was only raw HTML, no JavaScript engine. But that's changing. I think Google switched using JavaScript recently. And so as long as there's a link that goes somewhere, the search engine is going to be able to go there. And if going to that link triggers all the right thing, right? So if going to /weather triggers the content about the weather, then you're good to go. And the search engine is going to be able to index that page.
Okay, so it's just a JavaScript situation then.
Yeah, as long as the crawler has JavaScript enabled, then they're going to be able to reach these sections of your page. But you also want to make sure that your links are shareable. So if your link is not shareable, it's going to be much harder for an engine to find your content.
What do you mean by shareable?
Yeah, I mean if I'm here and I go to weather, right, I want the URL to change to reflect my place on the page. Right? So you'll have plenty of sites still where the URL doesn't change, but the content on the page changes. And so if the URL didn't change as I click these things, I could take my URL, put it on social media, and when you go there, when you click that link on social media, you wouldn't be seeing weather. You would be seeing the default state for that page.
Yeah, because it only
so
happens
here,
within that page, isn't it?
Yeah, so here you would have something broken, and that would be much harder for search engines to figure this one out.
So like the search engine would have a better or an easier time in that other mode you first showed us, this code pin. Then what was it? The debug mode, where your browser address actually changed.
That's right. Yeah.
Search engine could deal with this, okay, but back in the previous tab, it wouldn't know because your URL is not changing.
That's right. That's correct. Yep. So I click weather. It says /weather here. I take that link. I talk about it. I blog about it. I put it on social media, and then a search engine can go to that link and see weather information. That's important for the search to actually work. That's what I meant by shareable. Good. Okay. So as you can see again, it's pretty simple to build this stuff for yourself. There's nothing magical about frameworks. Good. So one last thing that frameworks do for you is allow you to test your app. That's something that you could do on your own, but it's kind of nice to have a bit of help. And if you've done the homework, you've used Jest, and that's what React is using, but Jest is also standalone. You can use it without React nicely. And the other frameworks that I looked at, they mostly utilize something like Karma and Jasmine. So Karma is the runner, and Jasmine is the library for specifying tests and expectations and that kind of thing. So these two together can help you test your code. Good. Good. So let's just have a look at React as an example. All right. So what choices has the team React made of all the things we've talked about? Right. So they use JSX for rendering views. So JSX is very similar to what we saw earlier with HTML plus JavaScript for rendering views. Right? So you actually use JavaScript to specify what the view should look like. Okay, so that's one choice they made here. And then they use a virtual DOM for modifying the UI. So they know how to render an in-memory tree from state, and they compare that virtual DOM with the actual DOM before making the changes to the UI. So that's the choice they made here on how to modify the UI. And then when it comes to URL routing, they're using a React component. So this is not, I guess this is not part of the core of a React. But basically they've used these two technologies and a few patterns to give you a React component that you can use for URL. So if you want to specify a link to a section on your page or to a different component, you can just use a link tag, and that's gonna give you a way to point to another component. And they use Jest for testing. Okay. So you could look at different frameworks and see what decisions they've made in all the categories that we've looked at, and that's probably a really good exercise, and is going to give you a good idea of how a framework is working, and what's going to be easy with that framework, what's going to be harder, and whether or not that framework is a good choice for your specific project.
What's Flux and Redux used for? Because this is something that they always bring up when they talk about React.
Yeah, there's a bit of a domino effect. So Flux is more like a pattern, and Redux is an instantiation of that pattern. So if you're going to spend time looking into this, I would look into Redux. Not so much Flux. But you can have a look at Redux, and that is separate from React. It's often used. The React people really like Redux, but it's actually separate from it, and it's just a way for you to manage your state. Okay. So in the examples that we had today, we had a simple global object. Maybe it was just a list of to-dos, and that was our state. Okay. In a real application, you'll have a lot more. You'll have a user object. You'll have maybe follower objects for that user. You'll have to-dos. You'll have a lot of things to manage in that object. And once you have a lot of state, you might just be overwhelmed by all the things that you have to do. And Redux can help you stay sane, if you will. So it's going to give you a model to take care of your state, and it's going to give you ways or suggest patterns for you to handle changes to your state, and for you to handle what needs to happen whenever my state changes.
Okay.
Yeah. Good. So yeah. If you want to learn the framework, I suggest React, but of course you're free to pick whichever one you want. If you do pick React, make sure to have a look at this quick start guide, and it'll run you through these really basic concepts in React. Right? So an element in React is really just a virtual node. Right? So it's a little section of the virtual DOM. A component is kind of a higher abstraction, but it goes around the element, and it has state and behavior. Okay, and each component is responsible for its own state and behavior. And that's it. So when it comes to state, we have props, which in this terminology is not state. Props are basically constants that get passed onto your component. Right, so you can see props as settings or options for your component. And if the props ever change, they shouldn't, but if they usually won't change often, but if the props change, the whole component is going to be destroyed. Okay, so within your component, you can assume that props don't change. Right? That's the concept here, and that's really an optimization. You could fold the props into state, but it would make it harder for React to know when to update the component. So it's just an optimization here. Props are just options that never change. And then the next concept is state. So that's the stuff that can actually change within your component. So if you have a to-do list component, the state is probably going to be a list of to-dos. And then whenever that state changes, your component is responsible for knowing how to render itself from that change. And then you have JSX, which is an extension to JavaScript. and it gives you a power that's very similar to the second example we had today with JavaScript in a template tag. So yeah, so these are the basic React concepts. Have a look at the quick start guide if you want to know more. If you're looking for alternatives to frameworks, have a look at these four: Angular, Vue, Ember, Aurelia. Along with React, those are the ones that I would recommend looking into. If you go beyond that, I think you run the risk of just running out of steam. And there's a lot of frameworks out there. At some point, you have to filter down and focus on one or two of them. So I would pick from these five. And if you look at the State of JS survey, these are also the most popular, the ones you'll hear about, the ones that can help you get a job, the ones that can have really good resources online.
Have you looked at Angular 2 yet? And because people keep saying that it's more like React. And is it something that you would recommend as well? Like any particular reasons for preferring React over Angular 2, for example?
Yeah, so Angular 2 is more like React in the sense that it's been componentized. So you can build components and they interact together. That is not necessarily a concept that you had in Angular 1, although they kind of retrofitted it to Angular 1. So if you use Angular 1.6, for instance, you will have access to components as well. And at that point, the line between 1 and 2 kind of blurs. But most people were using Angular 1.4, something like this, without components. And that's kind of what they mean when they say Angular 1. Angular 2 has components, so it's more like React, which is nice. It just seems to be a good idea to componentize your code base, makes things simpler. I looked into it a little bit. I'm not sure I recommend it as a first framework because it's more complicated than React. And they also use TypeScript, which is something that you'd have to understand and look into if you were to use Angular. It definitely helps in terms of documentation as well, if you can read TypeScript. Whereas React, whereas React uses ES6 mostly, which is nice, which is what we've been using so far. Yeah. Also, Angular 2 is kind of new. The documentation isn't completely there, and yeah. So basically, I would recommend React before Angular if you're new to it. But if you're comfortable and self-reliant and you're happy to go into it, I would say go for it. There's nothing wrong with Angular. The Angular team really created a nice framework with version 1, and they've kind of taken it to a new level with Angular 2. It's an interesting project, and it's probably going to be very popular as well.
Because the thing I found difficult when I was playing with React is just to kind of the simple tasks of setting up a project. If you want to put like things like Webpack onto it, and then you've got the whole Babel stuff, and I find you spend like 2 days just getting like an application going, and then by the point you just give up.
Right. Okay. Well, so unless you're really opinionated, this should not be a problem.
Mm.
So if you look at create React app, for instance. So this is the homework, right? So the idea will be to build a to-do app using a framework. Right? So you can have a look at the to-do MVC project that we talked about last time. And the idea will be for you to build these 4 features of the to-do application. Okay. So if you wanted to use React, I would recommend the Create React App project, right? And this project is basically a starter for you. So you can clone this code, and you're already set up, and you don't have anything to do. Babel is there, Webpack is there. You'll have everything set up, and you can just get going.
Cool.
Yeah. So yeah, you definitely should not spend a long time getting set up. If it's just a personal project, there's no reason to spend a long time on this stuff.
Cool.
Yeah. So you can have a
look
look
at the
instructions.
CLI as well? Sorry, did they have this? Did they have a CLI in React? Like Ember's got one, I think.
Yeah, that's true. Did they have a CLI? Well, Create React App has one.
Okay.
You can generate things. I believe.
Oh, it sounds
But,
like it, doesn't it? It sounds like that's it. Because you can install that and it puts all of that in for you.
Yeah, actually, I'm not sure. Create React app. Create React app. So yeah, so it'll help you generate your app like this. But no, I guess it doesn't have a CLI.
Okay.
But I mean, I don't see that as a bad thing. It's just simpler to me.
Yeah, I mean, as long as it's there, because this is the problem I had in the past, is to just get everything working together, and then you had to kind of update NPM packages that weren't compatible with each other, and anyway, it kept being like an ongoing process.
Sure. So that problem hopefully is solved by a project like Create React App, or you might have like a Yeoman generator that can solve that problem for you.
Okay.
You really shouldn't have to do this yourself.
Cool.
Yeah. Good. So yeah, so that's the homework. And once you've done these 4 features, you can keep going here. There's going to be some extra material here. And if you want to deploy your app, you can do it using Search or something like this. And then you can make your app public. And if you do this, feel free to share the link in the Slack channel. We can look at your app. Yeah.
Cool.
Good. Any final questions?
No, not particularly. Thank you.
Yeah, good. All right, well, thank you. And we'll talk next Thursday, or this Thursday at the same time.
Cheers.
Thanks.
Bye-bye.
Thanks, all. Yeah.
Thanks, Matt.
Thank you.